Question 4, we've got a particle on a smooth plane and the acceleration is given in component form, as you can see. Given some facts about the fact that it passes A at 0 and B at 5, passes through the point A at that certain speed, and we're supposed to find the speed of the particle as it goes through B. So I've redrawn the situation. I've got the velocity written here, I've got the acceleration, and the two positions t equals 0, t equals 5 of this particle. We're asked to find the speed of the particle. Again, this is an important word, as it passes through B. As we're told we've got a constant acceleration, we can use suvat. And I'm going to use suvat with that direction as positive. So let's fill in the blanks. S we're not interested in. U is the -16 business here. V is what we need to know. The acceleration is the 2.4 business here. And T is 5. Which equation links U, V, A and T? Well, it is V is equal to U plus AT. So there's U, just a copy and paste. And here I've multiplied both components of the acceleration by 5. Adding the separate I and j terms together, I get that V is equal to -4i plus 2j. But that's not what they want. They want the speed, so we need to square both these terms and take the square root. So that the speed is equal to the square root of 4 squared plus 2 squared. So if we work that out and simplify it and leave it in third form, I get 2 root 5. And that's the answer for part A. Okay, part B. The situation has got a bit more complicated. We've now been told the position of the particle at position A, and we've also been told the position of the particle as it moves to position C at time t equals big T, capital T. And we've been asked to find the value of t. So everything else remains the same. Its starting velocity is the same, its acceleration is the same, but now we've got a distance travelled. So let's set up suvat again, and I'm going to yet again treat this direction as positive. Now, the distance travelled from A to C will be this value minus this value. So this is going to be 4i plus cj minus both these terms, which is 44i, plus 10j, because the sign has changed. So I might as well work that out now. So I get -40i plus c plus 10j. The initial speed is what it was before, which is -16i minus 3j. The final velocity we don't care about. The acceleration is 2.4i plus j, and the time is big T. And the equation that links all that lot together is S is equal to ut plus a half at squared. So the concept is not difficult, it's just that the arithmetic is a bit gruesome. So if I come up here and write all the terms down, this is my value for S, copy and paste, multiplying the ut, here's the u multiplied by t, and this is a half a here, multiplied by t squared. Now that looks quite gruesome, but what we can do, because this is an equation, we can equate the I or j components and solve for t. If I equate the I components, I get this. This is a quadratic in t, and if you factorize it by whatever method you choose, including a calculator, you get that t is equal to 10 or 10 over 3. We're told that t is greater than 5, so this solution can be rejected, and our answer becomes that t is equal to 10 seconds. Part C asks us to find the value of c. Well, we've now got the value for t. So if I equate the j components and then substitute t is equal to 10, I should find c. And there is that equation. C plus 10 on the left-hand side is equal to this bit of the equation added to this bit of the equation, the 0.5j. So if I now substitute t is equal to 10, I'll find that c is equal to 10 as well. And that's the answer to part C.